In this video, we're going to look at the relationship between intermolecular forces and physical properties. So let's start by defining some of our major physical properties that we're going to look at in this class. The first one is boiling point. And boiling point is the temperature at which a substance goes from a liquid to a gas, or it boils. So temperature when a substance changes from a liquid to a gas. The next one we're going to look at is melting point. And melting point is similar to boiling point in that it's a temperature when a substance changes from a solid to a liquid. So melting point is the temperature when a substance changes from a solid to a liquid. So these two are both similar, and both of these physical properties are going to be strongly influenced by the strength of the intermolecular forces or the intermolecular attractions. So the stronger, remember, if we think about intermolecular forces as something that's holding molecules together, close to each other, the stronger those forces, the more energy it's going to take to break those attractions. So when we're talking about temperature, as it requires more energy to break attractions, that temperature is going to have to be higher, so that point is going to go up. So if you have something with really strong intermolecular forces or really strong intermolecular attractions, it's going to take a lot of energy to change it from a solid to a liquid, and then it's going to take a lot of energy to change it from a liquid to a gas. So as those attractions get stronger, the melting point and the boiling point are going to go up. As those attractions are weaker, the melting point and the boiling point will go down. So substances that are gases at room temperature don't have strong intermolecular forces because it doesn't have to reach a high temperature in order for them to be in the gas state. Likewise, if something is a solid at room temperature, it has stronger intermolecular attractions because the temperature needs to be higher in order to get it from a liquid or to get it from a solid to a liquid. Then if something's at a liquid at room temperature, it's kind of in between because it has enough energy to go from a solid to a liquid, but not enough energy to break the attractions to go from a liquid to a gas. So melting point and boiling point are both influenced by the strength of those attractions in the sense that the stronger the attractions, the higher those points are going to be. Those 2 points can also be affected by the masses. So when we talked about London dispersion forces, if there aren't any other intermolecular attractions, London dispersion forces are also influenced by the mass of the particles. So London dispersion forces are between all covalent molecules. And so as those particles are more massive, those intermolecular forces are stronger. So that also means in relation to the melting point and the boiling point, as those particles get more massive, it's going to take more energy to break those attractions because those attractions are stronger. The next physical property we're going to look at is vapor pressure. And vapor pressure is the pressure of a gas on the liquid. So it's the pressure exerted by gas particles colliding with the surface of the liquid. So pressure from gas particles on the surface of a liquid. And the vapor pressure is related to the boiling point. So if the boiling point is lower, the vapor pressure is going to be higher. So if we think that in order to have a high vapor pressure, you have to have a lot of gas particles exerting pressure or force on the surface of a liquid, That means as your intermolecular forces go up, as they get stronger, your vapor pressure is going to go down because there aren't going to be as many gas particles colliding with the surface of the liquid. As your intermolecular forces are weaker, you're going to have more gas particles because there's going to be a greater number making that transition from a liquid to a gas. And so there's going to be more collisions and therefore more pressure from the gas on the surface of the liquid. So vapor pressure is the opposite of boiling point and melting point in terms of the relationship with the intermolecular forces. The last property that we're going to look at is solubility. And we've talked about solubility a little bit in terms of ionic and covalent and polar and nonpolar covalent. But let's just refresh. Solubility is the ability of something to dissolve. So ability for a substance to dissolve. And so we can have lots of different solutes or things that we can dissolve solids in. Water is our most common because water has lots of different intermolecular forces, so it can interact with other compounds in a lot of different ways. Whether or not something is going to be soluble depends on what intermolecular forces both the solute and the solvent have. So solute is what's being dissolved. And the solvent is what's doing the dissolving. So for example, if we're going to talk about dissolving salt in water, salt is going to be our solute and water is going to be our solvent. And water, like I said, is one of our most common solvents because of its intermolecular forces, and that affects its properties. So when we're looking at solubility, the common phrase that you'll hear with solubility is something called like dissolves like. So if the solute and the solvent have similar intermolecular forces or like intermolecular forces, they will dissolve. So one example, if we're thinking about polar and nonpolar molecules will not dissolve in a polar solvent because those don't have the same intermolecular forces. Whereas if you have a nonpolar solute, you need a nonpolar solvent in order for it to dissolve. So that's where the like dissolves like comes in. So when you're trying to decide if something's going to dissolve, you need to look at what are the properties of each of the two materials. So if they have things that are in common, that's what's going to cause it to dissolve. So you have to kind of look at each of the materials separately, analyze what their intermolecular forces are, and then how those intermolecular forces are going to interact with the other, either the solute or the solvent, and that will tell you whether or not it dissolves. If they're like, then they'll dissolve. If they're not alike, then they're not going to dissolve. So those are just some of the ways that our intermolecular forces affect some of our most common physical properties of materials.